is a number of vectors in a basis of Rn, right? The number of vectors in a basis, and we know the all base has the same sign, so that's the number of bases give us the dimension. So we just need to find a basis of Rn, right? And then we check that whether there are exactly n vectors in this basis, and therefore we can conclude that this vector space is n dimensional. So here's one basics. We show that say E1, like canonical basis, E to En is a basis of Rn. So E1 is just, so E or EI is just vector whose ith entries is 1 and otherwise 0. And 0 elsewhere. Alright, J's entry is 0. J different from I. Okay, so this is the basics. How to check a set of vectors is a basis of a vector space. We know that we need to check two conditions, right? First condition, we check that they are this set E1 or E1 to En are linearly independent, right? And this is linearly independent because one way is we have n vector in the vector space Rn. So before we didn't know about the dimension yet, but we know this Rn column vectors. So we have n column vectors. We just need to check that the matrix which is the identity matrix I1 In, this is actually the identity matrix is non-singular, invertible, and this is equivalent to this set linearly independent. Okay, so here's the way. And the second step, we need to check that on the vector E1 to En span the whole vector space. And this is true because any vector, say vector V in Rn, say x1 to xn in Rn can be written as a linear combination of E1 to En, x1 E1 xn En by the two conditions. The first one satisfies they are linearly independent. The second one is they span the whole vector space. This implies that this set E1 to En is a basis of Rn. Maybe I should write a set notation E1 to En. And hence, therefore, we have Rn is n dimensional. So for similar other exercise, we do the same. When we check the dimension of a vector space, we just need to find a basis of that vector space, and the number of vectors in the basis give us the dimension. And to check the basis, we know we need to check two steps: linear independent and span the whole vector space.